Hey folks, welcome to my channel number pen. So there we have the problem on the screen. Integrate the following with respect to x. I have sine to the power 5x into cos cube x, right? So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down our y using the integral symbol. So that's my y. And I know that I do not have y in a very simple format whose antiderivative I know from first principles. So therefore, the job in hand is to simplify y. So how do I do that? I notice that I have a sine expression and I have a cos expression. And by this time, I'm sure you folks are familiar with d by dx of sine x equals cos x, right? So I can definitely solve this by the method of substitution. And what's that substitution I'm going to make? I'm going to make a very simple t equal to sine x. And why am I doing that? You will understand this in the next step, because when I differentiate this, I know that my dt becomes equal to cos x dx, right? And I go back to my y and I notice that I have a cos cube, right? So can I write my cos cube as cos into cos square, right? And why am I doing that? Because when I do that, which you will understand in the subsequent step, an entire term can be represented using t. My y, which is nothing but integral of sine to the power 5x, I write my cos cube as cos square into cos, right? So what happens? My cos cube is rewritten as cos square x times cos x and have my dx, right? Now you notice I have my dt equals cos x dx, right? Let me highlight this in yellow. And I have a cos x dx term in my y as well, right? Now I go to the next line. I can rewrite my entire y using t, right? What's that? My sine of x is nothing but t. So my first term becomes t to the power 5, okay? And then I have a cos square. And I know that my cos square of x is nothing but a 1 minus sine square x, right? So what happens is 1 minus sine square x becomes 1 minus t square. So we're using a very basic trigonometric identity. Sine square x plus cos square x equal to 1. Therefore, my cos square x equal to 1 minus sine square x. And that helps me represent my cos square x also in terms of t. Then I come to my cos x dx. I know that it is nothing but a dt, right? That also stems from our substitution what we made. So now I have y equals integral of t to the power 5 into 1 minus t square dt. I'm going to expand this, and when I expand, I notice that I will get t to the power 5 minus t to the power 7 times dt. From here on, I don't think it's very difficult. I'm going to apply the sum rule of integral and rewrite this particular expression y as integral of t to the power 5 dt minus integral of t to the power 7 dt. From here on, it is a cakewalk. I know that integral of t to the power 5 dt is nothing but t to the power 6 by 6, right? And then I have integral of t to the power 7 dt, which is nothing but t to the power 8 by 8. And not to forget my constant c, right? Now, I know that I cannot leave my answer in terms of t. I'll have to put back everything in terms of x. So all that I do is wherever I have a t, I replace it by a sine x, because that's the original substitution that we have made. So there we are. My answer to this problem is y equals sine of x the whole power 6 divided by 6 minus sine of x the whole power 8 divided by 8 plus c, right? Let me highlight my final answer in pink. So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.